Let's say that you have a team of individuals who worked really hard to create an application. Now imagine that this is the code of that application, and it is your responsibility to deploy this code on a server and get it up and running so that the outside world can now start using this application. If you prefer to host this application on an on-premise infrastructure, then you have to spend a lot of time procuring the servers, configuring the network, installing the software stack, etc. So you would rather want to use a service from a cloud service provider. In case of AWS, you have a service called EC2 or Elastic Compute Cloud, which allows you to create virtual servers with just a few clicks. And these virtual servers are as good as physical servers, except that you don't have to spend a ton of time configuring the infrastructure. Now technically you should be able to deploy your code on EC2 instance, and you should be able to get the application up and running. But things are not so simple. If it is so straightforward, then AWS would just be offering this service alone, which will allow us to create virtual servers, and we should be good to go. However, that's not the case. In all likelihood, realistically speaking, we might need to use some of the other services offered by AWS. For example, EC2 instance has a storage, which is like a computer hard drive. This is the disk that is physically attached to the virtualization host, where the virtual machine or the virtual server is residing. But unlike a real hard disk, it's a temporary storage. Once after you stop and start the server, all the data in that storage is gone. Hence, you can only use it for storing temporary data, like for example, caching frequently accessed web pages, etc. If you want a more reliable way of storing the data, you might want to use another service offered by AWS, something like EBS or Elastic Block Storage, which is essentially like an external hard drive attached to the virtual server instance. But unlike the instance storage, EBS can reliably store the data, meaning that the data would still be intact even after stopping and restarting the server. Typically, we tend to store persistent storage data that requires frequent read-write operations like a database, operating system files, or application data, etc. And then we also have S3, stands for Simple Storage Service. Is not really designed to be used as a primary storage, but is designed to store static content like videos, images, audio files, backups, etc. in a cost-effective way, and is also more reliable. As an example, if you were to deploy an application like Netflix, then the application would be running on EC2 instance, whose database would be residing in EBS, and all the video files might be residing in S3 bucket. Similarly, just as with any other application out there, your application might be using a database. Again, you can install the database on the EC2 instance itself, or you can use dedicated services offered by AWS. For example, RDS for relational database or DynamoDB for NoSQL database. These services will do a lot of heavy lifting for you and save you a ton of time and effort required to provision the database, management of backup and recovery tasks, or management of security patches, etc. Similarly, you got a bunch of other services. For example, you have AWS Cloud9, which is an IDE that lets you write, run, and debug your code with just a browser. This is going to save you from needing to install a local IDE, SDK, and plugins for your development machine. And if your application is performing data analytics, then you may want to use a service like Amazon Athena, which will allow you to perform data analytics on the data present in S3. Now, EC2 comes under the compute category. We also have a bunch of other services that fall under compute category, but I'm not talking about them right now because I want to keep things very simple for this video. Similarly, EBS and S3 would fall under storage category. We have RDS and DynamoDB falling under database category. AWS Cloud9 comes under DevTools, and Amazon Athena comes under Analytics. Likewise, we have a host of other categories of services. For example, we have migration and transfer. These are a bunch of services which will help you migrate your on-premise infrastructure to the cloud environment. And you also have services related to augmented reality and virtual reality, blockchain, machine learning related services, game tech, network and content delivery like virtual private cloud, virtual private network, etc. You have services related to robotics if you want to build robots, security, identity, and compliance, which will help you configure the access rights and privileges for your users. And we also have services that will help you communicate with an orbiting satellite. You've heard it right. And all these services sort of work together to perform the given business task. And there are hundreds of services in AWS. Now the real question is, do you need to learn all the services? The answer is, of course not. Even as a solution architect who is expected to have a broader perspective of the entire cloud ecosystem, even they don't have to know more than, say, 60 to 80 services. And if you specialize in one particular area, like a security specialist or a developer, then the services that you want to use might just be limited to, say, 30 to 40 services. So nobody is going to ask you to write a code to communicate with the orbiting satellite. You don't have to know everything. Hope it makes sense. If you like this video, you should also check out my other video which is on the same topic. Link to that video is in the description below. Make sure you watch it. I've also kept some useful resources on this topic. Again, you're going to find them all in the description below. But before you leave, do like and subscribe. The current subscriber count of this channel is embarrassingly low, and this channel is really struggling to take off despite putting a lot of effort to create good content. It only takes a couple of seconds for you to like and subscribe. I don't really expect you to share this video because I understand it's a difficult task to do, but if you do it as well, it helps this channel and keeps us motivated to bring you more quality content like this. I'll see you in my next video. Have a great day ahead.